Hi everyone, and welcome to today's lecture on exponential functions. So make sure that you have a pen and paper ready, and we're just going to start right away. So first of all, what is an exponential function? An exponential function is one that either grows exponentially or decays exponentially. So here's an example, y is equal to 2x. So let's maybe get an xy chart to see how this is, say, different from say a polynomial or a quadratic function. So let's say when x is 0, y is equal to 1. When x is 1, y is equal to 2. When x is 2, y is equal to 4. When x is 3, y is equal to 8, and so on and so forth. So what you can see is that this function will grow really fast as x increases. So this is an example of exponential growth. Exponential growth. And what this looks like on a graph, as you will see, is that, let me just maybe do a different color, is that it sort of grows exponentially this way. But however, it reaches a limit. It gets close to 0, but never ever actually reaches 0. So right over here, you'll see an asymptote. Okay? Let's show an example of an exponential decay. So an example of an exponential decay would be y is equal to half to the power of x. So once again, let's just get an xy chart going. So if x is 0, y is equal to 1. If x is 1, y is equal to half, because we put 1 over there, it's half to the power of 1 is half. If x is 2, it's half to the power of 2, which is a quarter. If x is 3, it's half to the power of 3, which is an eighth. So you can see that it's sort of decaying. In other words, it's getting smaller and smaller and smaller. So what would this look like on a graph? Oops, let me just sort of draw a straight line here. So say you have that. And so what this would look like is it would actually begin to decay like that. And again, once again, we have an asymptote over here. So this is an example of exponential decay. So I'm just going to write exp decay. Okay. So let's get to a more general form so we can sort of understand how these work. So more generally speaking, here's the equation. Y is equal to a b to the power of x plus c. So a in this case is the vertical stretch. B in this case is the growth rate. It's called the growth or decay rate. Okay? And C is the asymptote. Okay? So what you should have observed, at least from before, is that when B is greater than 1, we have exponential growth, as we saw with, y is equal to 2 to the power of x, right? And when b is in between 0 and 1, then what we have is exponential decay. So as an example, we have y is equal to half to the power of x. Okay, so let's sort of start graphing these and just get an idea of how to basically graph a couple of these functions. So let's do y is equal to 2 to the power of x plus 1. So the first thing you must always do whenever you get an exponential function is draw the asymptote. So our asymptote here is 1. Actually, you know what I'm going to do is I'm going to just draw just y to the power of 2x. So first of all, we need to determine what our asymptote is. And in this case, our asymptote is 0. So really, we could have just said 2 to the power of x plus 0. So the first thing you can draw is the asymptote, which is 0, which is right there, right? And since we know that b is greater than 1, this is exponential growth, so as a rough sketch, we can just basically say that this is growing up there, okay? Let's try a different graph. Let's try y is equal to 2 to the power of x plus 1. So what this would do in this case is the first thing we have to draw is the asymptote. So we can see that the asymptote is +1. So we would draw that right there, right? And we can see that this is 2 to the power of x, so it's exponential growth. So it would grow right up there. Okay, let's look at some sort of different variations of that. So how would we draw, say, okay, I'm just going to draw this one again, so as a comparison. So how would we compare 2 to the power of x plus 1 to y is equal to 2 to the power of negative x plus 1? So as we stated before, right, the first thing we have to do is find the asymptote, which is +1, okay? And this would just grow exponentially right there. Now in this case, the second one, if you recall from transformations, what that negative does is, all it does, it's just a reflection across the y-axis. So if it's a reflection across the y-axis, okay, we still do the same thing. We still do the same thing, which is first we always draw the asymptote, which is 1 in this case. So draw the asymptote there, okay? And because it's a reflection, it's really just a reflection of this across the y-axis, it will look like that across the y-axis. So really this ends up being exponential decay. And another way of seeing that, if you're comfortable with just a bit of algebra, is that y to the power of negative 2x is really like saying 2 to the power of negative 1 to the power of x plus 1. And if you know what 2 to the power of negative 1 is, I'm just going to write it, it's running out of space. So 2 to the power of negative 1 is really half to the power of x plus 1, which makes sense because that is an exponential decay graph right there. So 2 to the power of negative x is really 2 to the power of negative 1 to the power of x, and that is 2 to the power of negative 1 is half. And once again, as we said, since b is less than 1, that indicates exponential decay. This white arrow is just sort of an extension of this formula. That's it. It's not, has nothing to do with the graph. Okay, so that's basically how. Oh wait, there's a couple more. Sorry, just one more thing. Well, how does this compare 2 to the power of x plus 1 compared to y is equal to negative 2 to the power of x plus 1? So as we said before, right, always draw the asymptote first. So we have this, and this is growing up, right? Now, if there's a negative over here, this just means that it's a reflection, right, across the x-axis. It's a reflection across the x-axis. But what happens is that because we have an asymptote, our asymptote now sort of becomes our axis. So in other words, it's really just a reflection across the asymptote. So let's draw this. How that looks like is we have this over here, right? So let's draw the asymptote, which is 1 over here. And since 2 to the power of x grows up like that, a reflection across the axis would actually end up looking like this. So that's how, when the negative's in front, that's how the reflection would be. Finally, let's just do another example where we have reflections across both the x and the y. And remember, now it's really just a reflection across the y-axis and the asymptote. So once again, let's just draw this 2 to the power of x plus 1, and let's do negative 2 to the power of negative x plus 1. So once again, the first thing we draw is the asymptote, and this obviously is an exponential growth. The second thing we draw, okay, is here's our axes. I know it's not the straightest line, but you know, I'm sure it'll do. Okay, so once again, we draw the asymptote first. Now, what this negative tells us is that it's a reflection across the asymptote, so it would look like this. But don't forget, we also have another one. So instead of that, so I'm just going to erase this. So what that would mean is that we have sort of two reflections. The first one, I'm just going to erase that because that's not exactly what we want. The first one is, let me just draw this back. So this is how 2 to the power of x would look like. A reflection across the y-axis would make it look like that. And now a reflection across the y-axis would make it look like that. So I know I drew a lot of things. Maybe I'll just use different colors. So this is what 2 to the power of x looks like. Okay. After the first reflection, maybe I'll just use a different color. So after this first reflection, it would look like that, right? And then after the second reflection, which is over here, it would flip across and look like that. So the green line, this line over here, is what this function really looks like. Okay? So you can see that there are two transformations. This was the initial one. With the blue arrow, with the negative over there, it was reflected across the asymptote, which led to the blue sort of line over there. And then since the green arrow was a reflection across the y, it just flipped it across, so it ended up looking like that. So the green line is the final thing. Don't include the red or the blue. The red or the blue was just to indicate how the transformations occurred in order for you to get that graph. So let's sort of do something and see if we understand it. So let's do one more. So let's say y is equal to 3 to the power of negative x minus 4 over there. So we have that. The first thing we have to draw, obviously, is the asymptote. We know that it's negative 4. So that's negative 4, right? So normally it would go up like this because b is an exponential growth. But because there's a reflection over here, it would go like that. And since there's another reflection, it would end up like this. So that's how the last graph would look like. That's how this graph would look like. I hope that helped. And meet me in the next video where we start going over some growth and decay problems.